For 54 minutes, 4 people were the loneliest humans in the history of our species. They were not on the moon, they were behind it. A wall of rock more than 2,100 miles across stood between them and every other living thing in the universe. No radio could reach them, no signal could find them. Nothing on Earth even knew in real time whether they were still alive. This is the story of those 54 minutes. What the Artemis II crew saw through the window, what their instruments quietly recorded while the planet that built them sat helpless on the other side of the rock, and what one of them said the moment the silence finally broke. The 4 people in question were Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. 3 Americans and 1 Canadian. Wiseman was the mission commander. Glover was the pilot. Koch and Hansen were the mission specialists. They had been training for this moment for years. None of them, no human alive, had ever done what they were about to do. The Orion spacecraft they were riding in, nicknamed Integrity by the crew, lifted off from Kennedy Space Center on April 1, 2026. It carried them across nearly 250,000 miles of empty space in 5 days. By the time they reached the moon, they were already farther from Earth than any humans in over 50 years. They had already broken the Apollo 13 record. At their farthest point, they were 252,756 miles from home. Roughly 100 coast-to-coast drives across the continental United States, stacked end to end, with nothing between them and home but vacuum. At 6:44 p.m. Eastern Time on April 6, 2026, the signal cut. Mission Control in Houston stopped hearing them. The Deep Space Network antennas in California, Spain, and Australia, the same dishes that listen for spacecraft past Saturn, lost line of sight. Orion had slipped behind the moon, and from Earth's perspective, the 4 astronauts simply vanished. What did they see in that silence? Inside the cabin, the moment of signal loss was almost mundane. The console did not flash red. There was no alarm. The voice loop with Houston simply stopped being a voice loop. One moment, a controller was talking to them. The next moment, the line was empty static, and then silence. The crew had practiced for this so many times that the actual event was, by training, supposed to be uneventful. They knew where they were. They knew what was happening. They were on the far side of the moon, and for the first time in their lives, they were unreachable. The first thing they saw was Earth itself, leaving them. If you have ever watched a sunset from the deck of a cruise ship, you know how the horizon eats the sun in pieces. The bottom touches the water, the disk gets smaller, a sliver of orange remains, and then nothing. Earthset, from the moon's far side, works the same way. The difference is what is setting. The thing sinking behind that horizon was home. Earth shrank to a blue and white crescent, then to a thin curve of light along the lunar horizon, then to nothing. The moon swallowed it. NASA later released the photograph. The agency dated it 6:41 p.m. Eastern, 3 minutes before the official blackout began. Imagine seeing that with your own eyes. Every person you have ever known, every road you have ever driven, every meal you have ever eaten, every conversation you have ever had, all of it compressed into a crescent of light sinking behind a rock, and then gone. Nobody on Earth saw what happened next in real time. The crew was on their own. The moon's far side is not the dark side. It gets just as much sunlight as the side we see from our backyards. The name dark side comes from a different kind of dark. The far side is dark because no human eye had ever directly seen the whole of it. Spacecraft photographed it starting in 1959, when the Soviet Lunar 3 probe sent back the first grainy images. Orbiters have mapped every square inch, but until April 6, 2026, no living person had looked at the whole far side through a window with their own eyes while it was lit by the sun. The far side does not look like the near side, not even close. The side of the moon we see from Earth is dominated by huge dark plains called maria, the Latin word for seas. Those plains are frozen lava, ancient floods of molten rock that filled in older craters billions of years ago. The far side has almost none of that. It is a different world. Where the near side is smooth and dark in patches, the far side is brutally pocked. Crater on top of crater on top of crater, going back to the formation of the solar system itself. Nothing covered them up. Nothing healed the wounds. The far side is what the moon looked like before something, somewhere, decided to give the near side a face. Why is the far side so different? Scientists still do not fully agree. The crust on the far side is thicker, which probably prevented the same kind of lava flows that flooded the near side. Some researchers think a second small moon once collided with the far side billions of years ago, plastering it with extra crust. The debate is open. What the Artemis II crew brought back in high-resolution images from a vantage point no satellite has ever held in quite the same way is a fresh stack of evidence for both sides to chew on. And there is one feature on the far side that dwarfs everything else. The South Pole Aitken Basin is the largest confirmed impact crater anywhere on the moon. It is about 1,500 miles across and roughly 5 miles deep at its lowest point. To picture that, imagine a hole as wide as the distance from New York to Denver, and so deep that you could stack the Grand Canyon inside it 4 times and still have room. The impact that formed it may have excavated material from deep inside the moon, which means future lunar landers could touch rock that has not seen sunlight in 4.5 billion years. The Artemis II crew got the closest direct human look at it that anyone has managed since photographs first reached Earth from Luna 3. One feature in particular finally revealed itself in full. The Orientale basin is the youngest large impact crater on the moon, formed roughly 3.8 billion years ago, when something massive hit the lunar surface and excavated a hole so deep and so wide that the resulting shockwave punched concentric rings of mountains hundreds of miles across. From Earth, we can only see the eastern edge of Orientale, peeking around the limb of the moon at a sharp angle. The bulk of the basin sits squarely on the far side. Until Artemis II, no human had ever seen the whole thing. On day 4 of the mission, before the flyby itself, the crew released a photograph that showed Orientale in its entirety. 3 concentric rings of mountains, like ripples frozen mid-spread on the surface of a pond. Except the pond is solid rock, and the ripples are tall enough that you could stack the Empire State Building inside them and lose the building completely. Spacecraft like Lunar Reconnaissance Orbiter have imaged Orientale 1,000 times. Photographs and human eyes do not register a place the same way. The crew saw the entire basin with the naked eye. They suggested names for 2 newly noticed craters on the rim: Integrity, after their spacecraft; Carol, after a contributor to the program. The suggestion stands as the first time a crewed moon mission has nominated lunar features since the Apollo program ended in 1972. While they were still drinking in the geology, the second thing happened. The sun went out. Here is the geometry. Orion, behind the moon, was on a trajectory that placed the lunar disk almost perfectly between the spacecraft and the sun. For the people on board, this meant the moon eclipsed the sun. Not for 2 or 3 minutes, the way it does for someone standing in a field in Texas, for nearly 54 minutes of total darkness. That is roughly 7 times longer than the longest total solar eclipse ever recorded from the surface of Earth. Almost an hour with the sun completely blocked. Picture what that means. The sun, the star that runs every weather system on Earth, every plant that ever grew, every animal that ever lived. Gone. Behind the dark silhouette of the moon, where the sun should have been, there was only the corona, the sun's outer atmosphere, glowing in a thin halo around the lunar limb. The crew put on eclipse glasses, the same kind millions of Americans wore for the August 2017 and April 2024 eclipses, and they looked. They could see planets. With the sun extinguished, the background of space was no longer washed out. Saturn appeared, then Mars, then Mercury, then Venus. Even Neptune, which is normally faint enough that you need a backyard telescope to find it, became visible to the unaided eye. 5 planets at once, hanging in a sky lit only by a corona of plasma and a wash of stars. There is no human in history who had ever been in a place to see what those 4 astronauts saw in that moment. No Apollo crew ever witnessed it. The geometry simply did not work for them. Even on Earth's longest total eclipses, the duration is a small fraction of what Orion experienced. The corona itself was a scientific bonus. The Sun's outer atmosphere is normally impossible to study because the photosphere, the bright surface of the Sun, drowns it out. Total solar eclipses are the only times humans get a clean view, and even those are brief. Orion had 54 minutes. The instruments on board, including specialized cameras designed to image the corona during the planned eclipse window, captured detail that Earth-bound astronomers can only collect during actual eclipses, which happen at any given spot on the ground, maybe once every several hundred years. The data is still being processed by teams at multiple research institutions. The corona is what most people picture when they imagine the Sun without thinking about it. The wispy halo, the streamers reaching out like silver hair. It is a region of plasma heated to over 1,000,000 degrees Fahrenheit, which is hundreds of times hotter than the Sun's own surface. Solar physicists have spent careers trying to understand why the atmosphere of the Sun is hotter than the surface, a problem that violates basic intuitions about how heat works. Every clean observation of the corona is currency. Orion gave them an hour of it. The value of that data in research time alone is hard to estimate. Then there was the Moon itself, right outside the window. At closest approach, Orion was 4,067 miles above the lunar surface, roughly 1.5 times the width of the continental United States. By spaceflight standards, that put the spacecraft nearly on top of the Moon, and the lunar surface filled more of the view than any human being has ever experienced. Craters that fit easily inside the field of vision back home now stretched beyond the edges of the porthole. The shadows along the terminator, where day met night on the surface, ran sharp and long. Mountains the size of mid-sized American cities cast shadows hundreds of miles across the cratered floor. At that range, the Moon stopped being a disk in the sky and became a wall. Meanwhile, the crew's bodies were getting hit by something they could not see. Beyond Earth's magnetic field, the radiation environment changes completely. Cosmic rays, high-energy particles flung across the galaxy by exploding stars, slam into anything they pass through, including human tissue. A single galactic cosmic ray can carry energy levels millions of times higher than anything produced in particle accelerators on Earth. When one of them strikes a human cell, it can damage DNA in ways that radiation from medical imaging never approaches. Solar particles add to the dose depending on what the Sun is doing on any given day. Orion was instrumented with radiation detectors. The data from the far side transit, when Orion was also briefly shielded from solar wind by the bulk of the Moon itself, gave NASA a measurement that no previous mission has been able to provide. The contrast between exposure inside and outside the lunar shadow, recorded across roughly 50 minutes of changing geometry, is being used to refine the radiation models that will protect every future crew that goes deeper into the solar system. Mars missions depend on this kind of data. Long-duration lunar bases depend on it. The 4 astronauts behind the Moon were also, in a quiet way, lab samples. Then there was the silence itself. Inside Orion, the crew did not experience the eerie silence you might imagine. They could talk to each other. The spacecraft was running. The air handlers were humming. The instruments were collecting. What they did not have was contact with anyone outside that capsule. The radio loop with Houston was dead. Their families could not call. The news could not reach them. For 54 minutes, 4 people existed in a sealed bubble of consciousness, with the rest of the species locked outside. Mission Control had practiced this moment for years. They knew the blackout was coming. They had timed it to the second. When the signal actually dropped at 6:44 p.m., the room went quiet anyway. Knowing something will happen is one thing. Watching it happen is another. Every console operator in the room had to sit there, helpless, for the better part of an hour, waiting for the signal to come back. If something had gone wrong during those 54 minutes, there would have been nothing Houston could have done. No commands could be sent. No telemetry could be received. The crew had been trained to handle every contingency on their own, with whatever tools they had on board. The trust on both sides of the radio silence had to be absolute. The crew trusted the engineers who built the spacecraft. Houston trusted the crew. There was no middle ground. Stand inside that for a second. You are roughly 252,000 miles from the only home your species has ever known. The radio is dead. The sun is gone. The Earth is gone. The moon, larger in your window than it ever appears to anyone on the ground, is below you and around you. You can see craters older than continents. You can see planets that should not be visible because of solar glare. You are moving at thousands of miles per hour through a void that nothing on Earth can really prepare you for. And for the next 54 minutes, you have to trust that the machine you are inside and the people who built it did everything right. One specific detail came out of the post-mission interviews. As Orion approached the moment of reacquisition, the crew began to anticipate the return of signal. They knew the timing. They counted it down. Telemetry came back before the voice loop did, a steady stream of data showing that the spacecraft was alive. Every system reported nominal. Pressure, power, navigation, all green. The flight director in Houston had been watching the clock for nearly an hour, and when the data started flowing again, the room exhaled. Voice came moments later. Christina Koch responded with one sentence: "It is so great to hear from Earth again." That was the moment the silence broke. That was the moment 4 people stopped being unreachable. So what did Orion actually detect during those 54 minutes? Start with the imagery. Hundreds of high-resolution photographs of terrain that has been hidden from every human eye since the formation of the solar system. Wide-angle shots of the South Pole Aitken Basin from a fresh angle. Close-in views of the Terminator, the line where lunar day meets lunar night, where shadows stretch for miles across the cratered floor and reveal terrain features that vertical sunlight would have washed flat. Add the eclipse data. The corona was photographed continuously for nearly the full duration of totality. That is a longer continuous observation than any ground-based eclipse expedition has ever recorded in a single sitting. The wavelengths captured cover ranges that ground-based atmospheres absorb before they can reach a telescope. The instruments saw the structure of the Sun's outer atmosphere with a clarity that astronomers usually only dream about. Layer in the radiation profile. Cosmic ray flux, solar particle measurements, the specific shielding effect of having a 2,159-mile-wide rock between you and the Sun. NASA's models for crew exposure on deep space missions had been built on theory and on uncrewed probe data. Artemis 2 added the first crude validation of those models past the Moon. Stack on the spacecraft performance data: thermal control, life support, power systems, navigation, all running on autonomous protocols for the full duration of the blackout. Every system that will be needed for a lunar landing in 2028 and for Mars in the decades after was stress-tested in the one place humans have never been able to call for help. And the human element. The crew's physiological responses, their cognitive performance, their sleep, their interactions during the most isolated stretch of their lives. That data feeds into the design of every future deep space crew selection and training pipeline. There is something the instruments will never capture, though. It shows up in the photographs they took during Earthrise. When Orion came back around the Moon's far limb, the crew watched Earth re-emerge. The same crescent that had vanished an hour earlier rose above the lunar horizon. The crew photographed it through the window. The image shows Earth, tiny, suspended over a foreground of cratered grey rock. The angle is similar to the famous Apollo 8 photograph from December 1968, the one that has been called the most influential environmental photograph ever taken. The feeling is different. In the Apollo 8 image, Earth looks like a target. In the Artemis 2 image, Earth looks like a place you have just come back to. It looks smaller, more fragile, more found. The mission continued for several more days. Orion returned to Earth on April 10, 2026, splashing down in the Pacific Ocean off the coast of California at 8:07 p.m. Eastern. Navy divers extracted the 4 crew members and lifted them onto the USS John P. Mercer. Helicopters carried them back to a waiting aircraft. They were home in Houston the next day. The total mission flew 694,481 miles, roughly 28 round-the-world trips, roughly 250 cross-country drives. The next mission, Artemis 3, is currently scheduled for 2027. It will not go all the way to the Moon. It will test rendezvous and docking procedures closer to home. The first crewed lunar landing since 1972 is targeted for early 2028 with Artemis 4. By then, the data from Artemis 2's 54 minutes of silence will have been processed, modeled, and folded into every decision the next crew makes. The astronauts who eventually step onto the lunar surface will owe a portion of their safety to what 4 people quietly recorded, while the rest of humanity could not reach them. There is a phrase in space exploration that gets used too often: historic. The Artemis 2 flyby earned the word, not because the spacecraft was new, or because the crew was diverse, or because the trajectory was clever. It earned the word because of what happened during those 54 minutes. For the first time in human history, 4 people went somewhere we could not follow. They came back with images, with data, with measurements, and with a story that is not really about a spacecraft at all. It is about what we are willing to send out beyond ourselves, and what we are willing to wait for in return. The Moon has been the same moon for 4.5 billion years. It has been hanging in our sky since before there were eyes to see it. Almost everyone who has ever lived has looked up at it and felt something. Until April 6, 2026, no human had ever been on the other side of it. The rock had kept a secret for as long as anything in the solar system has kept anything. Then, for 54 minutes, 4 people sat behind it and learned the secret was just more rock, more craters, more silence, and the smallest, most beautiful blue crescent any of them would ever see. And that's it for this video. Thanks for watching, and I'll see you in the next one.